At the end of the last video, I asked you to try homework problem number 19 before tuning into this. That way you're getting a head start on the homework, but we get a chance to sort of review it together. Okay. So I've summarized the directions up here. The book has them as parts A, B, C, but basically this is all that we're asked to do. All right, so the first thing I want to do is get this into vertex form. So c of x right now is negative 2x squared minus 10x plus 4. I've separated the terms with x's in them. I'm hoping to be able to complete the square to make them look like a multiple of a perfect square. The number here, probably not the number that I want. It's just going to hang out while I do that work. Okay. So, first thing I'm going to do is factor out that number from the terms involving the x's. So that's going to become negative 2 times x squared plus 5x, and then there's my plus 4. But I didn't factor out the negative 2 from that. Sort of left a space here because I'm going to ultimately be adding something. Remember, I'm trying to make that quantity in parentheses look like a perfect square. I usually just write that as x plus d, some unknown number d, quantity squared. Remembering that that means I've got two factors of x plus d that I would FOIL out. And when I FOIL that out, the outsides and the insides give me two copies of d times x. So x squared plus 2 times some number times x plus that number squared is what I want to have inside of the parentheses. I'm already partway there. By factoring out the negative 2, I made it so that my first term matches, so that inside the parentheses I just have one copy of x squared. Now I look at the number of x's, and the number that I want is 2d. The number that I have is 5. If I set those equal to each other, that will tell me what this number d is. D is going to have to equal 5 halves. With that choice, these first two terms match my formula. So then d squared would equal 25 over 4. Now, I want to add that in here, but the only way I can do that is if I also undo it, because I'm not allowed to just change things. But if I add 25 fourths and then subtract 25 fourths, now make sure both versions, the positive and the negative version, are inside of these parentheses. I need this one to be the same place these x's are, but that means I'm going to be multiplying it by negative 2. So now I'm going to distribute it the negative 2 to break apart these parentheses. But rather than breaking it up into 4 pieces, I'm going to break it up into 2. Because those first 3 terms match my formula for a perfect square. So I'm going to say negative 2 distributes to those first 3 terms. And then negative 2 distributes to the negative 25 fourths. That's going to give me plus 25 halves. Now I still have my plus 4, which I'll write as plus 8 halves. And then I can say this is going to equal negative 2. Since that matches my formula for a perfect square, this factors as a perfect square. It's x plus d, where my d we had figured out had to be 5 halves. It's that quantity squared. And then this would be plus 33 halves. So now from here I can pick out the vertex. The vertex is going to be negative 5 halves. Do remember, don't forget that we need to change that sign, comma, 33 halves. And for graphing purposes, it might help to recognize that's negative 2.5 and then 16.5. Okay, so let's go ahead and graph this thing. Okay, let's see, where do I want to do that? I'm going to just erase the vertex because I'm about to draw it graphically. Okay, now, since my y value of my vertex is pretty high up, I'm going to use a fairly small tick marks on the scale on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8. You know what? I'm going to let these tick marks represent 2. So that's 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay. I'll go ahead and use the same. No, I'm going to use a different scale on the horizontal axis. So here's -1, -2, -3. Okay to use a different scale on the two axes, but make sure that you clearly indicate when you do that. So on the horizontal axis, my tick marks are 1 unit apart. On the vertical axis, they're 2 units apart. Okay, so let's see. We said -5/2, 33/2 was our vertex. Okay, so we've got it in vertex form. We've graphed the vertex. For the intercepts, well, I'm always going to have a y-intercept, which I'll get by plugging in 0. And in this case, I'm going to have x-intercepts too, because this is opening down. Okay. Let's go ahead and get the y-intercept first. So that's going to be 0, c of 0. Now, I could plug in 0 to this form. I think it's a lot faster to plug in 0 to this form. So strategic laziness says if I plug in 0, I'm just going to get 4. So that's right there. There's 0, 4. Okay. I can find the x-intercepts by either, the x values of the x-intercepts, by either setting this equal to 0 and solving, or this equal to 0 and solving. I've chosen this time just to do one more example of setting this equal to 0 and solving so that we can remember how to solve by taking square roots. But again, either option is fine. So the first thing I would do, I want to isolate that square, so I'm going to subtract over the 33/2. And then I'll divide by a -2, so we get x plus 5/2 squared. The negatives will cancel. Remember, dividing by -2 is like multiplying by -1/2. So this becomes 33/4. Now, that is a positive number. That's consistent with the fact that my vertex is up here and we're opening down, so that I should get some solutions. So if I take the square root of both sides, we get the absolute value of x plus 5/2 is equal to the square root of 33/2. Remember, when I'm taking a square root, I take the square root of the top and the square root of the bottom. In this case, the top doesn't work out nicely, but the bottom does. Okay. So x plus 5/2 is plus or minus root 33/2. Now, these guys are not like terms, because this is a rational number. I can write it as just a fraction of integers. Anytime I have a square root that doesn't simplify, that's an irrational number. So I can solve for x by just saying this is x equals -5/2 plus or minus root 33/2. And since these have a common denominator, if I wanted to, I could say that's -5 plus or minus root 33 all over 2. So those are going to be the x values of my x-intercepts. Now, I do want to be able to estimate where that is, so I need to know what integers root 33 is in between. Okay, so let's see. Let me just keep up here that those are the x values that I found. Okay. Root 33. If I square it, I'm going to get 33. Okay. Well, 36 is fairly close to that, and I get that by squaring 6. The next smallest integer would be 5, which squares to give me 25. So that tells me that root 33 is somewhere in between 5, let's make that a 6, 5 and 6. Okay. So if I take a look, if I were to say this was 5 here, -5 plus 5/2, that would give me 0. If this were 6, this would become -5 plus 1/2, that would be 1/2. So for the adding one, I should have written out, that's what I was doing, -5 plus root 33/2, okay, that's going to be in between 0/2 and 1/2. Okay. So I can say that's going to be somewhere there-ish. There's my -5 plus root 33/2 comma 0. Now, if I look at negative 5 minus the square root of 33 over 2. Okay. If this were 5, negative 5 minus 5 would be negative 10 over 2. That would be negative 5. If this were 6, I'd have negative 11 halves. So this is going to be in between negative 11 halves and negative 10 halves, which is just negative 5. So it's a little bit to the left of negative 5. That's going to be my negative 5 minus root 33 all over 2. And now I can play connect the dots. So there's my vertex, pass through those intercepts, and there's my graph of my parabola. Okay, let's see. We were asked to find several other things. Let's hope I can remember them all. The axis of symmetry. Remember, that's just the vertical line that cuts this into two equal pieces. So that's the vertical line through the vertex. It's the vertical line whose x value is the x value of that vertex. We were asked to find the value of the max or the min. Well, because this one opens down, there has a max. There's a max, so the value of the max. And we were just asked to find the value. That means the y value. How high up is it? That's our 33 halves. And we were asked to find the domain, which is automatically just going to be negative infinity to infinity. And then the range, that's my y values, and I can see that's everything at and below that maximum value. So, listing from smallest to biggest, that would be negative infinity to 33 halves. Make sure you've got a parentheses around the negative infinity and a bracket around the 33 halves.